Linux just crossed a line Windows can't follow. And this time it didn't happen with a loud announcement, a marketing slogan, or a headline-grabbing launch event. It happened slowly through years of steady development, quiet innovation, and a relentless commitment to an idea that Windows, by its very nature, cannot fully embrace. This isn't about which operating system has more users or which one ships on more laptops in retail stores. This is about something far more fundamental: control, freedom, adaptability, and the future shape of computing itself. For decades, Windows defined what a personal computer looked like and how it behaved. Windows 95 introduced millions of people to graphical computing. Windows XP became a cultural icon. Windows 7 refined the experience. Windows 10 unified Microsoft's vision across devices. But while Windows was perfecting its product-driven model, Linux was quietly becoming something different. Not just an operating system, but a foundation that could morph into countless forms, serve radically different purposes, and exist outside the constraints of a single company's long-term strategy. That difference has now grown so large that Windows simply cannot cross into Linux's territory without fundamentally ceasing to be Windows. One of the most important differences between Linux and Windows is ownership. When someone installs Windows, they are not truly receiving an operating system in the traditional sense. They are entering into a licensing agreement. Microsoft grants permission to use Windows under specific conditions, on approved hardware, with rules that can change over time. Microsoft decides when support ends, which processors are acceptable, which security chips are required, and which features are included or removed. Even when you pay for Windows, you are not buying it outright in the same way you might buy a physical object. You are renting access to a controlled ecosystem. With Linux, the situation is completely different. When you install Ubuntu Linux, Fedora Linux, Arch Linux, Linux Mint, Debian, OpenSUSE, Pop_OS or Manjaro Linux, you receive software released under open-source licenses that explicitly grant the freedom to study the code, modify it, share it, and build upon it. No corporation can revoke your right to use Linux. No company can remotely disable your system. No vendor can suddenly declare your perfectly functional hardware obsolete. You are not a customer in the Linux world in the same way you are with Windows. You are a participant. That single philosophical distinction already draws a line Windows cannot cross because Microsoft's business model depends on controlling Windows as a product. If Windows became truly open and community-governed, Microsoft would lose the leverage that makes Windows profitable. Adaptability is another area where Linux has pulled far ahead. Linux runs on desktops, laptops, servers, supercomputers, smartphones, routers, smart TVs, cars, embedded controllers, industrial machinery, and tiny single-board computers. Android is built on the Linux kernel. Chrome OS is built on the Linux kernel. Every supercomputer in the top 500 list runs Linux. Most of the world's cloud infrastructure relies on Linux. Even Microsoft's own Azure cloud runs massive numbers of Linux virtual machines. Windows, on the other hand, has gradually retreated from many of these spaces. Windows Phone is gone. Windows for embedded systems exists, but plays a minor role. Windows Server remains important, but Linux dominates in modern data centers. This reality reveals something crucial. Linux is not just competing with Windows as a desktop operating system. Linux has become the universal substrate of modern computing. Windows is primarily a desktop and enterprise product. Linux is a foundation that everything else is built on. What makes this possible is Linux's extreme modularity. A Linux system is not a single monolithic entity. It is a collection of components that can be swapped, replaced, and customized. On Arch Linux, you can start with a barebones system and assemble everything yourself. On Gem2 Linux, you can compile your entire system from source with custom optimization flags. On Fedora Linux, you get early access to emerging technologies like Wayland, Pipewire, and new kernel features. On Ubuntu Linux, you get a stable, predictable platform with long-term support. On Linux Mint, you get a polished desktop designed for ease of use. On Pop_OS, you get hardware-aware optimizations and advanced productivity features. These are not cosmetic differences. They represent fundamentally different approaches to what an operating system should be. Windows does not offer this level of structural freedom. You cannot replace the Windows shell with an entirely different window manager. You cannot swap out core subsystems. You cannot rebuild Windows to suit your specific hardware or workflow. Linux crossed a line when it made deep customization a normal, supported part of the experience rather than something hidden behind unsupported hacks. Update control further illustrates the divide. On Windows, updates are mandatory by design. You can delay them or pause them, but eventually they will install. Feature updates can change interfaces, introduce new behaviors, remove features, or even break existing software. Many users have experienced Windows updates that re-enable settings they deliberately disabled or reinstall bundled applications they removed. On Linux, updates are user-driven. On Ubuntu Linux, you use apt. On Fedora Linux, you use DNF. On Arch Linux, you use pacman. On OpenSUSE, you use Zisper. You choose when to update. You choose what to update. You can hold back packages, lock versions, or skip updates entirely. Linux treats the user as the administrator of their own machine. Windows increasingly treats the user as a managed endpoint within Microsoft's ecosystem. Privacy is another boundary Windows cannot realistically cross. Windows 11 is deeply integrated with Microsoft accounts, cloud services, telemetry, and online features. Diagnostic data collection cannot be fully disabled through official means. Advertising identifiers, cloud sync, and AI-driven services are built into the operating system. Linux distributions, by contrast, do not require accounts. Ubuntu Linux may ask if you want to share anonymous usage data during installation, but it is opt-in. Linux Mint does not include telemetry. Arch Linux includes none. Fedora Linux debates such features openly with the community. On Linux, privacy is not a premium feature. It is the baseline expectation. Microsoft could attempt to create a truly privacy-first Windows, but doing so would undermine the data-driven strategies that support its broader ecosystem. Security highlights another fundamental shift. Linux is built around a strong permission model, clear separation between user and system processes, and advanced mandatory access control systems like AC Linux and AppArmor. Most Linux systems can run for years without malware because the architecture itself limits what untrusted software can do. Vulnerabilities are often patched quickly because the code is open and can be inspected by anyone. Windows has made major improvements in security over the years, but it still carries decades of legacy assumptions designed for a very different computing era. Windows relies heavily on antivirus software, behavioral monitoring, and post-infection detection. Linux crossed a line when security became something baked into the design rather than layered on top as a corrective measure. Software distribution further shows how different these worlds are. On Windows, users typically download installers from websites, manage multiple update mechanisms, and trust each vendor individually. On Linux, most software comes from centralized repositories maintained by the distribution. You install applications from a single trusted source, and updates are handled alongside system updates. Flatpak, Snap, and AppImage extend this model with sandboxed cross-distribution packages. Windows now has the Microsoft Store and Wingit, but these are relatively new attempts to replicate a model Linux has refined for decades. Linux crossed a line when it made software distribution a core operating system function rather than an external activity. Performance and hardware longevity are another area where Linux has quietly pulled ahead. Linux runs efficiently on everything from tiny embedded devices to massive supercomputers. Many Linux distributions still run comfortably on hardware that Windows 11 no longer supports. Windows' increasing hardware requirements push users toward buying new machines even when their existing systems work perfectly well. Linux's ability to keep older hardware useful has environmental, economic, and practical implications. It reduces electronic waste, lowers costs, and extends the lifespan of technology. Windows cannot easily follow this path because its development strategy is tightly coupled to new hardware features and vendor partnerships. Transparency may be one of Linux's most underrated strengths. On Linux, you can inspect logs, examine configuration files, read source code, and understand what your system is doing. Problems are often documented openly. Solutions are shared publicly. On Windows, much of the system is opaque. Errors are abstracted. Internal behavior is hidden. Linux treats users as capable of understanding their systems. Windows often assumes users should not need or want that level of insight. The culture surrounding development also differs dramatically. Linux development is decentralized and global. Thousands of individuals and organizations contribute. No single company owns Linux. Even competitors collaborate on the kernel. This creates resilience. Linux cannot be abandoned, cancelled, or radically redirected by a single corporate decision. Windows is developed entirely within Microsoft. Its future is inseparable from Microsoft's corporate strategy. Linux crossed a line when it became a shared global project rather than a proprietary product. Containerization and virtualization further cement Linux's position. Technologies like Docker, Kubernetes, Podman, KVM, and QEMU originated in the Linux ecosystem and rely on Linux kernel features. These tools now define modern infrastructure. Windows supports many of them, but often through compatibility layers or Linux integration. The cloud-native world is fundamentally Linux native. Finally, user experience has evolved to the point where the old stereotypes no longer apply. Linux Mint offers a familiar Windows-like desktop. Ubuntu Linux offers a clean and modern interface. Fedora Linux delivers cutting-edge polish. Pop_OS focuses on productivity. Installing Linux today is often as easy as installing Windows, and sometimes easier. The idea that Linux is only for experts is outdated. Linux crossed a line when it became approachable without giving up power. All of these changes point to a larger reality. Windows is moving toward being a service-oriented platform centered around subscriptions, cloud integration, AI features, and ecosystem lock-in. Linux is moving toward being a user-controlled platform centered around freedom, privacy, modularity, and choice. These paths are diverging. Windows cannot follow Linux's path without dismantling the very structures that make Windows what it is. Linux is no longer trying to become Windows. Linux is becoming the universal operating system in the truest sense. A single core technology capable of adapting to almost any role, on almost any device, for almost any purpose. That is the line Linux has crossed, and it is a line Windows cannot realistically cross behind it.